Okay, here's the continuation of the 5.3 notes. We're going to talk about how to write an indirect proof. These are the three basic steps here. First, you state the negation of what you want to prove. So whatever you want to prove, you just assume the opposite. That may be a good idea. Instead of stating, maybe you could say assume. So I could cross that off and you could put assume the negation of what you want to prove. That might be a better way of thinking of it. 2, show that this assumption leads to a contradiction. So whatever you're assuming, you're going to show that that can't possibly be true, that there is some type of contradiction, that both your assumption and whatever the given is, they can't both be true, and therefore you can conclude that the assumption must be false, so what you wish to prove must be true. So let's do a little bit of practice. These aren't actual proofs, these are just little practices to show you what you would do for the first step. So this example number 5 says the shoes cost no more than $20. So would your first step be? Well, you would assume the negation of what you want to prove. So I'm going to assume the opposite. So I'm going to assume, maybe I can even write assume the shoes cost more than $20. There we go. That would be the first step in a proof. Next one says measurement angle A is greater than measurement angle B. Well, see if you could figure out what your assumption would be. Pause the video if you need to. Well, hopefully you said the measurement angle B is less than or equal to the measurement of angle B. Or measurement angle A is less than or equal to measurement angle B. Remember that this is the exact opposite of this, right? Because if I'm talking about all values, if A is all values greater than B, well, the opposite would say that it is all values less than or equal to B. All right, and then you've got to find the contradiction. So take a look at example number 6, see if you can figure out where the contradiction is. Well, hopefully you saw that both of these two cannot be true. Right? Because two lines cannot be perpendicular to each other and parallel to each other at the same time. That doesn't make any sense. Perpendicular, again, remember, perpendicular is like this. Means they intersect. Parallel means this. It means they never intersect. So obviously that can't be the case, right? And that's even kind of stated in the little symbols, right? So there you go. There's the steps. Let's do an actual proof here. I'll do example 7, and then I want you guys to try practice number 7, and then I'll just show you what I did for it. Now, the proof, normally a proof is actually you kind of explaining it. So an indirect proof will usually kind of be like a written paragraph, and so that's normally what you would put here. Let me fill in a couple things here because this should be 2x minus 3 is greater than 7. Over here this should be 3y plus 7 is less than or equal to 19, and y is less than or equal to 4. My computer just didn't have some of that information. Okay, well, first thing we're going to do, well, what am I trying to prove? I'm trying to prove that x is greater than 5. So I'm going to assume the opposite. So let's say assume that x is less than or equal to 5. Alright. Now what would that mean? If x was less than or equal to 5, that would change this statement. It would change my given. So we want to actually test what happens when I say that x is less than or equal to 5. Well, with an inequality or with an equation, an easy way to test what happens in those situations is just to make a little table. And let's just see what happens. So let's pick some numbers that are less than or equal to 5. These aren't the numbers that I would use in every case. They're just the numbers that I would use to test my assumption. So some numbers that are less than 5, well, I could less than or equal to 5, I could say 5, I could say 4, I could say 3, I could say 2. Right? I don't need a lot. 3 or 4 is plenty. So let's plug that in. Well, if I was to plug a 5 in for x, 2 times 5 is 10, minus 3, that is 7. 4 times 2 is 8, minus 3, that is 5. 3 times 2 is 6, minus 3, that is 3. And 2 times 2 is 4, minus 3, that is 1. Okay, well, let's look. 2x minus 3 is supposed to be greater than 7, but is that what's going on here? No, all of these values are less than or equal to 7. Not greater than 7. So this cannot be true. X cannot be less than or equal to 5. So we could say that. We could say, therefore, x cannot be less than or equal to 5. So just draw a little line through it. So x has to be greater than 5. Boom. That's it. Like I said, I just kind of took you through the logic of a proof. I didn't actually write out a paragraph, but you can try that on the next one. Next one being this example down here that we're going to go to in a little bit. But just practice the logic here on practice number 7 and see if you can figure it out. You should pause the video and try it, and then I'll explain it. Okay, so let's do all the same things. I want to prove that y is less than or equal to 4, so I'm going to assume the opposite. I'm going to assume that y is actually greater than 4. So let's test that. Well, make a little table. And again, this table is just for when I'm proving equations or inequalities. That's really what I'm doing here. You'll see in example number 8 that I don't even make a table. It's just it's a whole different method of testing my assumption. That's all I'm really doing here is I'm testing my assumption. Okay. Shoot, that's not what I wanted to put there. I wanted to put a y here, so let's just cross that out. Y. Okay. So I need to test my assumption. So I need to test values that are greater than 4. Well, now I can't include 4 because this is not greater than or equal to. It's just greater than. So let's just pick numbers like 5, 6, 7. Those numbers are all greater than 4. Let's test them. 3 times 5, if I was to plug that 5 in for y, 3 times 5 is 15, plus 7 is 22. 3 times 6 is 18, plus 7 is 25. And 3 times 7 is 21, plus 7 is 28. Okay, well, let's see here. These numbers are not less than or equal to 19. These numbers are actually all greater than 19. So let's just say that these numbers are greater than 19, and they are not less than or equal to 19. Well, see, that contradicts my given, right? This statement and this cannot both be true. So therefore, y cannot be greater than 4. So we know that y is less than or equal to 4. Hopefully you're seeing the logic. That's the most important part for you to just understand the logic, understand the flow of these things. So once you do that, then these things become pretty simple. Okay. This last one. I want you to see what you would do here. Let me just fill in a couple of things here. This should have a little angle symbol. This should have a little angle symbol. But we're going to write an indirect proof given that n is not parallel to m. So we know right off the bat that these two lines are not parallel. That's a given. And we're going to prove that angle 1 is not congruent to angle 5. And generally, whenever you see a not, that's your hint to know that you're going to need to use an indirect proof. Yeah, so I want you to just try and maybe press pause and wrestle with this question for a little bit, see if you can figure it out. Well, the thought process is the same here. I'm going to assume the opposite of what I'm trying to prove. So if I'm trying to prove that 1 is not congruent to angle 5, I'm going to assume that angle 1 is congruent to angle 5. And then let's try and write this like kind of like a paragraph. So we could say that would mean we have corresponding angles so we'd have corresponding 1 and 5 are corresponding angles, corresponding angles that are congruent. Well, we learned a while back that if we have corresponding angles that are congruent, this is chapter 3, corresponding angles that are congruent, that means that these lines must be parallel. So we could say, so M and N must be parallel. Well, that contradicts the given. Therefore, again, those three little dots just mean therefore. Therefore, angle 1 is not congruent to angle 5. There we go. And that's it. That's how you would write an indirect proof. The next part of the next page is just the summary. See if you can do that on your own. Alright. Talk to you guys later.